Alright, now this is really the same kind of problem that we've been working with, but it's going to be a little bit more expansive, a little bit more general. Alright, so we're finding the equation to the tangent of y equals x squared minus x plus 9 at the point where x equals a. Hence, find the equations of the two tangents from 0, 0 to the curve. State the coordinates of the point of contact. Alright, so here we go. First thing that we need to do is we're going to find the slope. So if y equals x squared minus x plus 9, we're going to find y prime. Y prime is 2x minus 1. Now that means at a, the slope, right, the slope is 2 times a minus 1. Remember, whenever it was x equals some number, we always just took that number and put it in for x. And so that would then give us 2a minus 1. So now we're going to go y minus y1 plus, equals m times x minus x1. Alright, so now we need a point. Now, a point, obviously, the x value is x, the y value is, well, I don't know what else it could be, so it's just going to be x squared minus x plus 9. Alright, and of course by that we mean at a, and so x is going to be a, and then y is going to be a squared minus a plus 9. And so we can go ahead and plug these in. We'll go y minus y1, which is a squared minus a plus 9, equals m, which is 2a minus 1, times x minus x1, which was just the a. And so from there, we're just going to simplify. And after we've simplified, we should get essentially the simplified equation that we're going to be able to work with. So let's go ahead and get y by itself. So we're going to go y minus a squared plus a minus 9 equals 2ax minus 2a squared minus x plus a. We're going to move everything over, so we're going to have y equals, let's see, if we plus the a squared, then we'll have a negative a squared, and then if we subtract the a, that will go away, and so I've got a plus 2ax, and then I've got a minus x there, and I've got a plus 9 when I add that 9 to the other side. Now, if you want to simplify this a little bit, you can write it as y equals negative a squared plus, I'm going to factor out the x here, so it's going to be 2a minus 1 times x, and then plus 9. Okay, so there we go. That's essentially the equation with a in it at any specific point a. Alright, so now it's asking us to find the equations of the two tangents from 0, 0 to the curve. And so what it wants us to find is the points of contact. So let's just say for a minute, here's my graph, right? It looks like it's been shifted up a little bit, so it probably looks something like this, right? So there's my quadratic, and it's saying, okay, here is 0, 0. Now find the two tangents. So you can imagine one of them is probably something like right here, right? And then the other one's probably something like right here. As you can see that there's two tangents there. It's asking for these 2 points, right? State the coordinates of the points of contact. So find the equations of the two tangents from 0, 0 to the curve. Alright, so these are what we're finding. Now, we've already got an equation. A is actually what we're looking for. And so what's been given to us is x and y. 0, 0. So we can go ahead and put in 0 equals negative a squared plus 2a minus 1 times 0 plus 9, and then we will just solve for a. So 2a minus 1 times 0 will be 0. I'll add the a squared to both sides, so I'll have a squared equals 9. We'll square root both sides, so that means a equals positive 3 or negative 3, right? Plus or minus 3, because I took the square root of the variable. So that's what a is. Remember, a is x, and so now I'm going to take that and I'm going to plug it back into the equation. So actually it wants me to find the equations of the two tangents. So in order to do that, first I am just going to take my general equation here. I'm going to put a into it, right? So let's do it for the positive 3. So if I put positive 3 in, then it's going to be y equals negative 3 squared plus 2 times 3 minus 1 times x plus 9. So that should be minus 9 and plus 9. So y equals 2 times 3 is 6 minus 1 is 5x. Alright, so there's one equation. So and then x is 3, so that would be 3 comma 15. Which is the point of contact. And then on the other side we'll do the negative 3. So this was x equals 3. Now I'll do x equals negative 3. So I'll go negative 3 squared plus 2 times negative 3 minus 1 x plus 9. The negative 9 and the positive 9 cancel out again, so I'm going to have negative 6 minus 1, which is negative 7x. So y equals negative 7x, which means 3 comma negative 21. And so that would be the intersection on that end. All right, so just a quick recap. First thing we did is we went ahead and found the slope. We did the derivative and found the slope. Once we had the slope, then we plugged that into the slope here. We said that x was a, and so we put that in, we put a in for x1. And then we said, well, if x is a, then a squared minus a plus 9 would have to be y. And so we put that in for y1 right here. And then we simplified it, and when we simplified it, we ended up with this guy right here. Now, that was helpful once we then said that we were finding the tangents from 0, 0, because we put 0, 0 in for x and y. We were able to solve for a. We were able to find the two values for a that would give us tangents then. Once we had those x values, we could plug them in for a, which then gave us this equation for the positive 3, which simplified to y equals 5x. And when we put the negative 3 in, it went to negative 7x. And then we were able to find the intersection points as well, which is 315 and, negative 3, negative 21. So, negative 3, positive 21 then. Good thing we caught that. So, anyway, there you go. There are your answers, and I hope that's helpful.